In lab this time, we're going to be discussing several different devices that serve very different purposes. Some of them can detect things that are nearby. Some of them can detect motion that's far away. We'll also talk about serial data transmission and receiving those transmissions. But the thing that unites all of these devices is that they use infrared signals to do this. So infrared, of course, is just like visible light. It's just that it's a little bit at a lower frequency, and so we can't see it with our visible eye. It goes down to red is visible, and then if you continue to go in that direction, you would become infrared. That's below red, which is what infrared means. So infrared light is really, for all characteristics, it's just like visible light, except our eyes are not qualified or not capable of seeing the infrared light. So we can use this infrared light for a lot of purposes in the same way that we use visible light for a lot of purposes. Interestingly, we don't use ultraviolet light for a lot of purposes, but infrared certainly serves a lot of valuable use for us. So the first thing that we're going to talk about is infrared proximity detection. Proximity is just a fancy word for seeing or detecting things that are nearby. And what we're going to do to detect this thing that's nearby is we're going to have an infrared pair. There's the clear transmitter and there's the dark receiver, which we've used before. And what's going to happen is that the clear transmitter is going to send infrared light out. And if there's an object there, it'll bounce back and it'll be detected by the dark receiver. And so here you can see that the interface to this device is about as simple as it can get. There's a power, there's a ground, and then there's the output. And the output is going to simply be high, or actually I think the output is going to be low if there is an object that's being detected. And then how far away can you detect it? Well, that depends on this little potentiometer right here. So we can set up the range for detection, but be aware of the fact that that range can vary depending on how reflective something is. Obviously, the whole way that this works is it's detecting reflections. So I pretty much guarantee you that it can detect something that's bright and shiny white, or like a piece of shiny aluminum foil, much better than it, or even a mirror, much better than it could detect, say, a piece of flat black material. So just be aware of that when you're working with the proximity detector. We need to make a few connections. You're going to connect the ground and the +5, of course, between the Arduino and the breadboard. Connect the output pin of the sensor, which is the leftmost of the 3 pins as you're facing the front of the sensor, to pin 8. And then we're going to use a piezoelectric buzzer to detect when the sensor goes off. So connect the non-grounded terminal. There's already one, there's a piezoelectric buzzer on your board, and the ground terminal is already grounded. Connect the other terminal to pin 4. And then here's the code that you can use. Notice that basically we're just going to say, okay, pin 8, that's the infrared proximity detector. We're going to set that up to be an input. Obviously, the buzzer is going to be an output. We're also going to send it out to the serial monitor. If we read that the proximity detector has gone low, that's what happens when an object is detected, then we're going to send out a beep for 100 milliseconds, and we're going to print to the screen that the object was detected. And then we're going to delay for 90 milliseconds. So we're not going to have a break in the tone as long as there's still an obstacle there. We'll have a continuous tone, and we'll repeat object detected, object detected, object detected. So what you should do is upload that program and then use the potentiometer with a little screwdriver to adjust the distance of detection so that it's about 6 inches from the end of the sensor, and play around with the potentiometer to verify that in fact you can adjust how sensitive it is. Passive infrared is different. Passive infrared is when you don't send an infrared light out and look for reflections. You look for the infrared light that's coming from objects that are nearby. Because it turns out that every object, unless it's at absolute 0, is going to emit light. This is known as black body radiation. And it's why if you ever watch like a blacksmith or like a glass blower, you'll see that those things that are super, super hot are glowing red or even white. That means that they're extremely hot because they're glowing in a visible spectrum. But even things that are not that hot, things that are, say, 98.6 degrees, actually emit infrared radiation. And so infrared light is something that we can detect quite well. And we're going to use what's called passive infrared to detect when there's a person moving nearby. And the great thing about passive infrared is that if a leaf blows by, for example, then you're not going to detect it because you're looking simply for changes in temperature. So here we're really looking for not changes in temperature. We're looking here for changes in temperature, not simply for the motion of an object in front of the screen. So passive infrared is the sort of device that's underneath this dome. This dome, it has a special type of lens that focuses the light down onto the sensor, and so that it can actually detect things that are maybe 20 to 30 feet away. I can easily trigger this sensor with the motion of somebody walking past my door at 20 feet. So what you need to do is connect this one. The middle pin here is the sensor output to pin 9 on the Arduino. And then here's a block of code that includes both the proximity detector and the passive infrared. If you see PIR, that's passive infrared, that'll be on pin 9. And really it's going to do the same thing, except the passive infrared is high when it is actually detecting motion. So we have to look for low on the proximity detector and high on the passive infrared. And you'll notice that I'm sending it out at 2 different frequencies here. So there are 2 distinct beeps at different frequencies so we can tell which one is which. And then once you get that, I even put a little box here for your professor or your lab assistant to initial that. Now, those were sort of preliminary. Those are more sensors. They're going to be valuable, for example, if you design a robot that needs to be able to detect walls or needs to be able to detect motion and take action. But infrared data transmission and receiving is really a much more common application of infrared signals. So when we think about IR, we think of like a remote control for your TV or your DVD player, your Blu-ray player, your DVR. All of those are really based on infrared signals. But the interesting thing is that if you had an infrared signal that was just being constantly transmitted, like a flashlight, it would actually only work out to maybe about a foot away, because there's so many other sources of infrared light in the room that they actually wash out the infrared signal coming from the remote control. So what we need to do is we need to find a way to be very clever and find a way to just detect the signal that we're looking for, the signal from the remote control, not the infrared that comes from black body radiation or not the infrared that comes from fluorescent light bulbs. And the way we're going to do that is by modulating the signal. When we say modulate the signal, we mean that we're going to turn it on and off very quickly at a very specific frequency. And then we're going to look for an infrared signal that is turning on and off at just that same frequency. I know that sounds very complicated, but it's actually basically a technology that's very well established, and it's easy for electrical engineers and computer engineers to use this same technology in a different sort of application. Well, it turns out that 38 kilohertz is the best frequency for this modulation because there's almost no interference sources at that frequency. For example, fluorescent light bulbs aren't going to have any sort of components at 38 kilohertz. Obviously, black body radiation won't have any modulated frequencies. It's a good frequency for us to use for this purpose. And so what we know is that if we just had DC, a transmission of the infrared signal, it would last maybe about a foot. But with the 38 kilohertz, your remote control probably could work 25, 30 feet away. And that's a lot more useful. If you had to get up and walk up to within 1 foot of the television to use your remote control, that's not really remote control. But from 25 or 30 feet away, it's just a fine remote control. So happily, this is so common that they actually make devices that are specifically designed to receive and demodulate the frequencies. So here we have a receiver that can also demodulate the 38 kilohertz and get it down to the sort of signals that we're looking for. So this device will output a series of about 16 to 20 bits, about 4 to 5 hexadecimal digits. And if we just take the last 16 bits, that's going to give us 16,000 unique codes. So if you have a remote control with more than 16,000 buttons on it, then you'll need to use a different device. But as long as that's not the case, then I think you'll be just fine. So here is some code that can be used to interface to that remote control. We have a remote control that is going to transmit to that receiver. And this block of code will allow you to use both of them together. So what we see then is that we have to use this library called IR remote. And so if you are trying to compile this code and it's not compiling, go into the include library function in the menu of the Arduino IDE and include the IR remote library. Once you do that, this code should compile just fine. There's some up here, for example, you can see receiver is pin 11. We have to have this block of or this line of code right here and this line of code right here. Basically, these are connecting the receiver to an object and then storing our received codes in a particular location. We're going to turn on serial communication, and we're going to start the receiver to be able to receive infrared signals. And then we say, okay, if there is a result that has been received or has been detected, then we're going to just take the last 4 bits, the last 4 digits, last 4 hexadecimal digits, and we're going to see which one of these codes was it. Because these are all the codes that are on that remote control that I'm going to give you for lab. If you take a remote control from home and you try to zap it, it probably won't correspond to exactly what these numbers are, but these are the ones that are on the remote control you're going to have in lab. And then we're going to delay 200 milliseconds so that we don't have multiple detections of the same press. And then we'll go ahead and resume and look for the next button to be pressed. So simply we receive the code, and whatever that button corresponds to, we're going to print that on the serial monitor. And that's really all that happens. And so we have 21 different codes. We can display those 21 different messages to the screen, and that's going to allow us to interface between the remote control and our Arduino board. We can also actually transmit from the Arduino board as well. And so we have to use pin 3 of the Arduino. That's the only pin that can be used to transmit at 38 kilohertz, which is what we're going to need to do. And so we have a program here which can be used to receive, and I've shown here in red the lines that are new as compared to the previous program. I've added a button, so there's this push button that's connected to pin number 12. I need to enable sending of a transmission of an infrared signal. And I have to have a couple of variables here to contain the length and the value of the code that's just been received. I'm going to set the button pin, remember that's pin number 12, I'm going to set it to be an input, and I'm going to use a pull-up resistor. And so that pull-up resistor, of course, means that I will default to being high, but if the button has been pressed, then the signal will go low. The reason for that button is we're going to remember the last code that was just received, and if the button is ever pressed, we're going to echo that signal back out again. So we're receiving, button gets pressed, send the signal that we most recently received. So it's kind of like a programmable remote control in this way. So you can see here, when we receive a code, we're going to store the result into code value. We're going to store the number of bits into IR length, and we're going to display the results. And the displaying the results is now in a function. So the function is down here. That's exactly the same thing that was in the previous code. It's just that I put it into its own function now. But this is the new stuff. This is the magic right here. If we see that the button is low, then I want to send. And NEC is just a particular type of infrared transmission. I want to send the code value at the given length, and then I want to print a message to the screen that says sent the code, and then by the way, what value did we send? Oh, we sent code value. So one thing to know about this is that once you push the green button, or once you push the button to begin transmitting, then it actually locks it out from receiving it ever again until you reset the Arduino. So just be aware that you're pushing the buttons on the remote, and then you push the big button that transmits from the Arduino. Now it can't receive anymore until you reset it. So just be aware of that. And if you look at the demonstration video, you'll see that I mentioned that as well. So hopefully that will help to make that a little bit clearer. So once you do that, then the last thing is share it with another team. This will be the first time that you interact with another team really directly. I want you to transmit a signal to another team, and then I want them to verify that they can receive it properly. They can use either version, part B or part C of the code, and then you have to use part C to program it and then push the button to transmit to their receiver. And once you can do that, then demonstrate it to me or to the teaching assistant, and you're done for the day.